So following on from the previous video, we got to this stage here where we know the gradient here will be 0 and the gradient here will be 0, and then we can guess that a graph will look something like this: down and then go up and then we'll go down again. So we will guess our graph to be something like this. So now we need to detect if there's any point of inflection. So point of inflection, we need to find the second derivative of this. Okay, so in the previous video we've done the first derivative being this. Now we need to differentiate it. So when you differentiate this, it will then give you this. So now find out when f double prime will be 0. That will then tell us the inflection point. Okay, so once you get to this stage here, find out when f double prime will be 0. So it boils down to you trying to solve this. Now, if you try and make x a subject here, it's actually quite difficult. So use that technique in the previous video. Turn this and this into a quadratic equation. So let u equals this thing here. So if you let u equals this, then if you let u equals this thing here, then this thing here will become u, okay, and then this thing here will become this thing here, okay, and then now you've got this block equals this block, take away this block here, times everything by u. So this times u will be 0, and then this times u will be u squared, and this times u will be 2. Okay, so now add 2 to both sides and then square root, so u equals this thing here. So now u equals positive and negative square root of 2. So remember u equals this. We set u equals that earlier. Look, let u equals this. So once we've got a u here, translate it back into x. So u equals this. Okay. So now take the hang on. So once you're here, then take the natural log of both sides. Remember that we discard the negative version, because if you look at this here, if you take the natural log, well, then we're going to discard the negative version. Okay. So that will then give us this, and then this translates to roughly this. Okay. So the point is that we've got an inflection point at x equals the natural log of square root of x. So now find the normal function. Now find out f of the natural log of square root of x. That will then give you blah 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 blah. That will then give you this, okay, which is roughly this. Okay, so we've got an inflection point at well, looking at our graph here, we've got an inflection point at x being this thing here, and the y being this thing here. So these are the coordinates of our point of inflection. So we've got a point of inflection right here. Okay, right here. Okay, so what that means is that, as it turns out, to the left of this, f double prime will be less than 0, and then to the right of this, f double prime will be greater than 0. So what that means is, in this region, it will concave down. So hang on. So what? Oops. Hang on. So what that means is from the left. Oops. Oh man, sorry. Control D. Wait there, bear with me. How do I get rid of this? Okay. So hang on. Let me start again. So to the left of this, it will concave down. So what that means is, don't forget it has to go through this. It will concave down like this. Okay. It will concave down, and then to the right of our inflection point, it will concave up. So don't forget it has to go through this point here. Okay. so we'll concave up. So we'll do something like this, concave up. Okay, it will concave up. It will concave up. So what that means is our graph will look something like this: concave down and then concave up. See that? So overall our graph will look something like this. Okay.